In this movie, we're going to adapt the player controller script that is being created here to support physics. Previously, we could control this capsule object, moving it around the scene just as though it were a player character, but it paid no attention to the physical obstacles in the scene. Now, one way we can get around this for the player character is instead to use a character controller component. Now, by default, the player objects do not come with a character controller. So what I'm going to do to adapt my object for that is first of all select the player character. Now, if it already has a collider attached, as this object does, for example, this object has a capsule collider. In this case, I want to remove this collider because the character controller already comes with a collider built in. So I'm going to select the cog icon and a context menu will appear, which is off screen here, but there is an option that says remove component. So I'm going to remove the capsule collider. Now, still making sure that the player object is selected here, I'm going to choose component, physics, and then I'm going to select the component character controller. And when I do that, you can see that the character controller component is attached to the player object. If I zoom in just a little bit, you can see that we have now a collider attached to this capsule. We have the ability to change the properties about the size of that collider if we need to. For example, I can come over here to the radius and the height settings, and I can adjust these to accommodate the height of our character. But it just so happens that in this case, these default settings are perfectly fine for our purposes. So we have now added the character controller to this player object. Now, of course, if I, for example, raise this character up in the scene and I press play on the toolbar, nothing takes effect just yet. Even though we have the character controller component attached, we still have to do some extra things in our script file. So I'm going to stop playback here and double click on the player controller script here in the project panel. This is simply the code that we used in the previous video. So I'm going to double click on that to open that file inside MonoDevelop and bring that into view here. So you can see here we have the player controller C# script file. This file is included in the course companion files. I'm going to be adapting the code of this to support physics. So to get started at achieving this, I need to get a reference to the character controller component. Previously, we transformed the object by using the transform component. We still need access to that component, but I also want access to the character controller. So I'm going to add a new private variable and I'm going to call this character controller here. It should appear in the code completion menu. So I'm going to choose character controller and I will name this controller and assign it the initial value, of null. Now in the awake function, I'm going to get reference to that component by using the getComponent function, and I'm going to get a reference to the character controller like so, so that this expression is now assigned to the controller here. So now that I have a reference to the controller on this object, I can then come into the update function and make some amendments. Now the rotation of the character can be left just as it is. I don't need to change the rotation at all. But what I do need to change is the line here, line 29, in which we are adjusting the position of the player character. Here I'm doing this via the transform component, which provides no validation. I'm going to comment out that line. I could delete it instead, but in this case, I'm just going to comment it out in case I ever want to restore it. And I'm going to use the controller instead. So if I press the period symbol on the character controller, there is a function here called simple move. And notice that this argument, the argument for this function, is simply a vector 3, which defines the speed of the character. In fact, this more correctly defines the velocity of the character because we should specify not just the speed, but the direction in which we are traveling as well. So I'm going to choose simple move here, and the argument should in fact be the forward vector multiplied by our speed multiplied by the vertical amount. So I'm going to use this here to define the offset that we should use for traveling. Notice that I have not used the value time.delta time. And the reason for this is because the simple move function already multiplies this input value by time.delta time for us. It handles that automatically. So I'm going to press Ctrl S to save that code. And the last thing, in fact, I should do is change the update function from update to fixed update. And I'm going to save that code again. And the reason for that is whenever you interact with the Unity physics system, you should do that inside the fixed update function and not the update function. That is simply because the Unity physics system is synchronized to work with fixed update as opposed to update. So I'm going to save that code and return back to Unity here. Unity goes ahead and compiles this code. And it takes a while to do that. It's still thinking about that. And finally, the code is now compiled. So I'm going to test this out by pressing play on the toolbar. Notice that when I press play, the character immediately moved to the ground here. The physics or the gravity took effect. In fact, I can grab the player character, move him up in the scene, release my mouse, and again, gravity pulls him down. So that simple move function is already taking effect. And if I move the character around inside the viewport, he moves exactly the same speed that he was moving before, except this time I cannot pass through solid objects. So I can't walk through that pillar and I can't walk through this wall at all. So again, the character is completely trapped now inside this environment. He doesn't fall through the floor. Gravity does pull him down, but he doesn't fall through the floor because this floor is a solid object. And again, we have these pillars here. Now, if you are trying out this code and you find that the character is either falling through the floor or is passing through physical objects, it's important to make sure that your imported mesh object, which I've selected here, has a collider component attached. Otherwise, Unity doesn't recognize it as a solid object. So for this object, I have a mesh collider component. Now, I generated that when I imported the mesh. I did that simply by moving over to the meshes folder, selecting the imported mesh, and in the object inspector here, I ensured that the check mark was enabled for the option generate colliders, and then I scrolled down and clicked the apply button. So for your imported meshes, you can use the generate colliders option, or you could in fact go a different route and just select this object and use component physics and manually add primitive colliders to approximate the environment. Whichever way you go, your environment needs to have colliders, and so long as it does so, your player character, with using the character controller, will always be able to interact correctly with the physics objects in your scene.